Hello, this is Gnanishwar Saira, roll number 21951805552. This is my DMS Techtalk, and my topic is an algorithm for computing minimal bidirectional linear recurrence of relations. Abstract. We consider the problems of computing a linear recurrence equivalent, a linear feedback shift register of minimum order for a finite sequence over a field, with the additional requirement that is not only the highest but also the lowest coefficient of the recurrence is non-zero. Such a recurrence relations can be used to generate the sequence in both directions, increasing or decreasing for indices. So we will call it bidirectional. If the field is finite, a sequence is periodic. If and only if it admits a bidirectional linear recurrence relations. For solving a above problem, we propose an algorithm similar to Birkelmep-Messi algorithms and prove its correctness. We also describe the set of all solutions of the following problem and prove something properties of the minimal polynomials of initial segments of the sequence. Introduction. The well-known Birkelmep-Messi algorithms computes and linear recursive relations or equally a linear feedback shift register or a characteristics polynomial for a minimum order which generates a given finite sequence S0, S2, Sn minus 1. In a linear reconciliation, the coefficient of the highest term has to equal 1 or some non-zero element. The coefficient of the lower term is usually allowed to attribute including 0. If this coefficient happens to be non-zero, that we can actually use the linear recursion but the both ways to generate the terms of the sequence in the increasing order of the index. We also in decreasing order. We will call such a linear recurrence bidirectional. In this paper, we consider a small problem of the one I am solving the algorithm by restrict our research to bidirectional linear recursion relations. Namely, given a finite sequences, we want to find a binary linear recurrence of S minimum order. Note the order will be greater or equal to the minimum order of unrestricted linear recursive relations. The linear recursive relations computed by the Birkelmep-Messi algorithms will some case be bidirectional. When it is non-bidirectional, our algorithm will compute a bidirectional one by suiting combining some of the recursions computed previously in the algorithm. Moreover, our algorithm has a property that all intermediate minimal polynomials C of I for S0 to Si minus 1 with I is equal 0, 1 and minus 1 are bidirectional. Whenever possible, that is, whenever there is exists a bidirectional linear recursion relations among the unrestricted minimal linear recursion relations for S0 to Si minus 1, the algorithm is presented in section 3. We also describe the set of the bidirectional linear recursion relations of the minimum order for S. We prove the correctness of our algorithm, and in doing so, we will examine more closely the sequence of polynomial C1 x c n to the power of minus 1 x. We show the distribution of the bidirectional and the non-bidirectional minimal polynomials in the sequence must satisfy a certain property. See the 3.4 and quality 3.5. The linear recursion of the minimal order of the S is obtained by artificially increasing the order of the recursion by introducing k extra coefficient all equal to 0. In order to accommodate the terms in the pre-period which do not fit the linear recursion of the periodic part equivalently, if C of x is minimal polynomial for the periodic part of the sequence, then x to the power of k C of x is the minimally polynomial for the whole sequence. Hence, as far as the linear recursions relations are considered, there is no connections between the pre-periodic and the periodic part of S. We could indeed describe the sequence as two separate unrelated entities, a finite sequence or a periodic part and an infinite periodic part, we can then concentrate on the linear recursion relations of the periodic sequence. In a finite sequence is periodic, its minimal Lie recursion relations will be bidirectional. For infinite fields, the converse is also true. That is, an infinite sequence which has a bidirectional linear recursion relations will always be periodic. Recall that of the polynomial f. Over a finite field such that f does not x does not equals to f, there is an integer n called the order of f such that f if x power of n minus 1, see for example 3. Moreover, the finite sequences or finite examples, the following three notations are equivalent: recurrent, linear recurrent, ultimately periodic. One of the important applications of message theorem algorithm is a characteristics of the stream chippers. The key stream in a stream chipper is usually a sequence defined by some recursion relations over a finite field. Such a sequence is therefore a linear recurrent sequence and also ultimately periodic. If an attacker obtain access to the number of successive terms of a sequence, say via non-plain text attack, they can apply the Messi's algorithm to determine a linear recurrence relations of minimal order of the given finite sequence and hope that this relation in this fact linear recurrence will that generate the original infinite sequence. The number of successive terms needed in the order of the linear recurrence of the finite sequence equals to the one of the finite sequence terms of the equal to the twice the linear complexity of the finite sequences. When fewer terms are known, the linear recurrence of the finite sequence might or might not be coincide with the linear recurrence of the infinite sequence. In the order to improve the chances of determining the correct linear recurrence of the infinite sequence in the case, we can note that infinite sequence being periodic. Well, being bidirectional, minimal linear recurrence relations, we should there before restrict our self or bidirectional linear recurrence sequence for a given finite sequence. Background definition 2.1. Given an infinite sequence S not S1 or a finite sequence S not S1 to Sn minus 1 with an element in the field K, we say S is linear recurrence sequence. It satisfies the relations of the form Cl Cj Sj plus Cl minus 1 Sj minus 1 plus up to C1 Sj minus L plus 1 plus C0 Sj plus minus 1 is equal to 0. For all j is equal to L plus 1, so on. For all j is equal to L plus 1, so on, n minus 1 respectively, where C0, C1, Cl, Cl minus 1 belongs to K or constant and Cl is equal to 0. The equation 1 is called homogeneous linear recursion relations of order L and associated with the characteristic polynomial C of x. C of x plus 1 C naught is L is a minimum of a given sequence. We call L is a linear complexity of the S denoted by L of S. Recursion relations of the minimum order is called minimal. Recurrence relations is a characteristic polynomial of the minimum degree is called minimal polynomial. We normally concentrate on the monopotic characteristics polynomial since any of characteristics polynomials can be written in a monocharacteristics polynomial multiplied by non-zero constant. Similarly of minimal polynomials, none of the literature there are two different ways to associate a polynomial to non-recursive relations. The one is in the algorithm as shown on the screen. The table here we are running the BM algorithm of the sequence 0 1 1 0 0 1 0 1 0 1 1 0 1. We give the example of the running Messi algorithms on a binary sequence as you can see. Theorem 2.4. At the end of the messy algorithms, if the 2 degrees C less than n, then C of x is a unique monocriminal polynomial of the sequence. If 2 degrees C greater than n, the set of the monocriminal polynomials of the sequence is given by C of x plus Q of x B of x dot D of x minus m less than or equals to D of C minus D of B minus n minus m. Next we will see definition of bidirectional linear recursion relations. Definition 2.5. A relations recur- a linear recurrence relations as defined in the definition 2.1 is called bidirectional if C naught is equal to 0. A characteristic polynomial associated of the bidirectional linear recursion will be called bidirectional characteristics polynomial of a given finite or infinite sequences. A binomial characteristics polynomial which has a minimal degree among all bidirectional characteristics polynomials of S will be called a minimal bidirectional characteristics polynomial. Note that it may be not minimal polynomial of S. Hence, the characteristics polynomial is called the bidirectional if not divisible by x or equivalent to its free terms non-zero in a infinite sequence admits a bidirectional characteristics polynomial. In the particular sequence in the period, the minimum polynomial of the sequence being a factor of the characteristics polynomial will also be bidirectional. Note, if the any bidirectional linear sequence that can cover all sequence if the if given L successive terms of sequence Si plus 1 Si plus L minus 1, we can compare the both terms in the recursion non-bidirectional and the k is the smallest index which C by k is equal to 0. Then the terms is not S1 Sk minus 1 cannot be recovered given arbitrary L successive terms of the sequence algorithm. Our aim is to compute an monic Maynard bidirectional characteristics polynomial for the given finite sequences. We could start by applying Berkeley-Massey algorithms and the minimal polynomial thus the obtained will be some happen to the bidirectional when it is not. If the minimal polynomial is not unique, then try to find an attractive one which when can bidirectional as in theorem 2.4. This is achieved by the modifying the update formula else branch of in the second if of the algorithm 2.0. Algorithm we propose is a given algorithm 3.1 in algorithm and variables the same meaning in algorithm 2.2 we denoted by cibi and coefficient xi in the polynomial c and b respectively. Conclusion. Motivated by the importance of the bidirectional linear recursion relations of the capitalist applications, we developed an algorithm which computes a bidirectional linear recursion sequence of minimal degree of a given finite sequence. We also described how to obtain all recursions and give detailed description of the pattern of the bidirectional, non-bidirectional minimal polynomials obtained at the different stages of algorithms. Thank you.